Previous videos we have learned about several components of a time series dataset, particularly the trend, which indicate the particular behavior of this the time series dataset. In addition to that, whether there is a cyclic trend. Likewise, also we have learned about the randomness or the noise of the data in the previous videos. So apart from trend, there are also a cyclic component in a time series dataset. So it can be monthly, annually, or maybe even weekly. However, there could be situations we can't or difficult to identify what the seasonality is, or when the series continues from time to time. Maybe whether it is a weekly cycle or maybe it is a monthly cycle. So in these situations, we can use a periodogram in statistics. So basically, a periodogram is used to identify the dominance period of a time series. It is very useful identifying the dominant cyclic behavior in a series, particularly when the cycles are not related to the commonly encountered monthly, quarterly, or seasonality. So for this example, I am going to use a particular data set which includes temperature from 1950s, 1st of January to predictions up to 2099 December. So in this particular data set, you can find various ecological regions in United States. However, I am not going to use every ecological regions. For this example, I will use this Arizona, New Mexico mountains ecological region. So in here I have called the particular CSV file into the R. However, as I mentioned before, I am only in the first and second columns of this data set. Therefore, I am going to import only filter only those two columns. So we can check the data set from here. So we'll run this again. So now you can see here it starts from the 1950s 1st of January and ends from 2099 December. So first of all, what we have to do is we have to call a particular library called TSA, because without that library we can't actually draw a periodogram. So I name it as DP, and then we can call the periodogram function. So we have to specify the particular data set, and then we have to specify the column. And then we can also give a particular label also. So likewise we can draw a periodogram here and run it again. So by looking at here, you can see a dominant spike at a low frequency level. So as I said before, we use this periodogram to identify spikes or dominant spikes at a low frequency level. So if you zoom in, you can see here very close to 0.1 frequency level there is a dominant spike. So we can also further explore this periodogram. For that I am going to create a data frame here. So I am going to name it as B spike. and then we can assign data frame. So I'm going to reorder them in ascending order. So if you run this, you can actually see in which areas that we observe a dominant spike in frequency. So we'll run it again. So we have here Smith varied. So again run this. So by looking at this, you can see the spike was in 0.083. So this is why this is interesting is that in here we know we get the frequency value, and we also know 1 over time or equals to the frequency. So what I here done is that I have taken the 1 over this top 5 frequency value, so that eventually I will get the time. So when you run this, you can see here you get the 12. So by looking at that, you can see it takes 12 months to complete the cycle. So when you think about it, it is obvious, right? So the changing in the weather condition is normally happens annually. So this example is really obvious for us because we all know things like temperature, rainfall are annual phenomena. So it ought to have annual seasonal behavior. But in cases that we can't actually predict the seasonality, for an example like changes in stock market, cryptocurrency values, you can use this periodogram technique to identify the seasonality or the cyclic period.